Okay. So I'm wired up correctly. So can I thank the three Bs for inviting me here, and thank Hussein and his colleagues for arranging some truly life-threatening weather yesterday to make me feel that I've really come to the United States, because we don't really do life-threatening weather in the UK. No, not really. Yeah. So Barry and I exchanged some emails about what I'm meant to be talking about now, and the main word that appeared in both of them was confused. So I'm not quite sure what exactly I'm meant to be doing now. So I've put together something actually of how the sort of software development we're working on works in the UK, because it's so totally different from how it works here. But I think it's worth at least flagging up some of the differences. What I notice is that given the UK is a fairly small country and a reasonable sized academic community, rather a lot of the codes that have been advertised as being open access actually come out of the UK. So for example, take one example, ABC, which was being flagged yesterday as the only reaction code that was actually publicly available, was a CP6 flagship project developed by David Manolopoulos on EPSRC money, for instance. But there are several of them that appeared across the horizon. So I think it is worth thinking, how does the UK do it? It is very different from what we've been talking about here for the last few days. And then I'll get on to what I think my brief was actually to summarize the discussion here. But as you know, I don't think I need 20 minutes, half an hour to summarize what you've already heard yesterday in the discussion. I do have a few points. So the UK landscape well, I put all this down, it makes it sound like an awful lot's going on. And it is sometimes. EPSRC believes it is Maoist. It's a Maoist organization that believes in continuous revolution. So it may be happening this week, but it doesn't mean it happens next week or last week or next year. And in fact, EPSRC, I think, technically doesn't even exist anymore, because 15 years ago, they split all the research councils into 8 different ones. And a year ago, they decided the thing to do was put them all back into one again. So from April, they've all become UKRI. But as no one knows what UKRI is meant to be doing, for 1 year only, it's UKRI-EPSRC and no change. And then from next April, everything I say here may be irrelevant, because it may have all changed completely. Okay? So you've probably all heard of collaborative computational projects. They've been going since before I was even in this field. The CCP2 was founded sometime in the late 70s by Phil Burke and others. For really political reasons, it merged with CCP6 about 3 years ago and became CCPQ. And what the CCPs at least now do is provide small continuous funding for workshops, visitor exchange, plus support from government laboratory, largely Daresbury, that can be Rutherford. There are periodic calls for either flagship projects or software development calls. No one ever seems to be able to predict when they're going to come out. I think when there's some money in the tin or something. And whether they're a flagship project or a software development call also I can't predict. And what exactly the difference, I can tell you what the difference between these are meant to be developing new codes like ABC and so forth. And software development can be taking existing software and doing things with us. And actually, to their credit, under one of these software development calls, we got a couple of years postdoc to turn the really appalling Fortran in the UK R matrix molecular codes in something which approximated to 21st century Fortran. I mean, there are bits of that code which were in Fortran 2 at the point when we started the process. And I was amazed that anyone should fund us to do that. That was absolutely necessary to be done, if you see what I mean. These calls, they don't say they have to be multi-institutional, but the reality is if you're going for a multi-institutional bid, you're much more likely to get funded. They quite often can, so I'll come on to one Hugo's running at the moment, has two postdocs on it in different institutions, so there can be several PDRAs. The CCPs, collaborative computational projects, have support from Daresbury, from the permanent staff there, typically one or maybe a bit less than one person per year dedicated to your project. I think CCPQ has 0.9 of Martin Plummer. I don't know what he does with the other 10% of his time. But that's a typical idea. There are also high-end computing consortia, which is actually giving out computer time in large blocks to groups of people rather than medium-sized blocks to individual investigators. And the idea is these groups of people are grouped around running common codes, not necessarily for the same problem, and their access to computer time. And then when this is not running at the moment because we have a rather aged computer which needs replacing, but they have run targeted support for people to port codes from to the supercomputer with the idea of getting it to run efficiently and quickly on the supercomputer. And indeed, I had one of these last year. I'll talk about in a minute. And the guy who was chaired the DCSE, the original project I was on the panel, was a guy called Christian Bischoff from Darmstadt, who's a computer scientist, actually a very, very interesting guy to hear speaking. And he was very strong on something which he called green computing. What he means here is if you get your code to run 3 times quicker, you save a lot of electricity, a lot of computer power, and a lot of money buying the computer in the first place, and basically use the computer much more efficiently. And he was a very passionate advocate of this idea that for relatively small investments in person time, you could actually make much better use of the computers available, rather than just saying to investigators, apply for some time, put your ratty old code on there and get it somehow to limp through the machine. And he actually produced economic arguments that what the way they were spending the money actually was cost effective doing this. So you
computing, it's the best scenario.
Yeah.
It will save you money.
Yeah, exactly. So I hope that if, in due course, when we replace Archer, which is our current supercomputer, this sort of scheme will reappear. So there's heavy emphasis in this on, I put open source there, and actually it's slightly more nuanced than that. What they want is the UK academic community to have it open. Now that may mean that you can just shove it as an open source repository, but there are some of these codes which have quite a lot of commercial value, in which case you're quite welcome to charge industrial customers, either UK or international, for having them, but what they don't want to do is make barriers for entry for other UK academics to use the code. So it doesn't have to be completely open source. I already said that the multi-institutional investigators and bids are generally favoured. One of the things you'll be judged on is the user base. So if you go in and say, I've got this great idea and this great code, and everyone is going to run it within my group and no one else, you simply won't get funded. Okay? So they want you to show that there are going to be people around the country or around the world who are actually interested in running this. Industry engagement is a big thing. The UK, there's this word impact in the UK that appears everywhere, all over grant forms, all over things. The trouble is it means different things in different contexts, so it's a slightly difficult. And in fact, the grant forms now have academic impact and other impact, which is societal impact or industrial impact, as separate sections have to be filled in. But they're very keen on industry engagement, and the post-Brexit agenda, I think, has ramped that right up. And again, it's something I'll come back to. They like UK collaborators, but actually having international collaborators is sort of a benchmark of excellence. Because if someone from the States wants to use the UK code, that's a real test that actually we are internationally, we're well competitive in terms, and vice versa. If we put a proposal, if you want to use the US code, that's fine, but then you have to base it on doing the physics. You see what I mean? It's not a code development, and that's a different funding stream.
Collaborations, for example, to develop.
Yeah. Well, you can have collaborative development. I mean, that's fine. And there have been, and I'm sure you've been involved in, there have been various NSF, EPSRC schemes that have run. And then there's a big emphasis on workshops and training as part of the activity. So, I mean, Lincoln was talking about outreach. Actually, there's very little emphasis in any of this on outreach as such, but there's a lot of emphasis on actually upskilling people who are already fairly skilled, rather than getting in people at the 15-year-old stage, if you see what I mean. And I think Hugo already referred to the fact that the various computer centres run really very good high-level courses that you can go on and send your postdocs on, or your PhD students on, and train them up. So if we look explicitly in our area, it's actually rather good at the moment. If I'd given this talk 2 years ago, this would have been a near blank slide. We've had a good run recently. So CSBQ, already alluded to, has carried on pretty much continuously. I think it's funded for 5 years till 2021. It's not huge amounts, about £60,000 a year, maybe less than that actually. They're not talking about big bucks here, but it eventually is for community activities like workshops, meetings, bilateral visits, and then we have support, as I said already, from Martin Plummer. That supports quite a range of codes, not just the R-matrix codes, which I will talk about, but also Graham Worth's own activity on wave packet dynamics, and it actually has a group in Oxford and others who are working on spin tensor stuff as well, that has been developed under CSBQ as well. So it's a range of codes in atomic and molecular physics. Graham considers that to be a weakness because most of the other CCPs seem to all collaborate around one code, and I'll come back to that in a minute. Hugo has a flagship project with the Open University in Daresbury, working on multi-photon time-dependent physics using the R matrix formalism for both atoms and molecules. We just this month have started a high-end computing consortium, which is led by me with Belfast, the Open University in Daresbury, and that's a 4-year project, and I'll talk a little bit about that as well. And then, for example, I had one of these ECSE support programs last year, which was 12 months. It was a former PhD student of mine who they funded for 12 months as a postdoc to actually, and what he actually did was take a code which I started over there 20 years ago writing to construct our Hamiltonians for the molecular code, and it was a ratty code when I wrote it 20 years ago, and it hadn't got any better over 20 years. And what I...
like fine wine?
No, they get worse. I don't think codes mature like fine wine. I hacked old Fortran 20 years ago, and then it was, you know. So what Ahmed actually did was throw it away and start with a blank piece of paper and wrote using Fortran 2003 constructs an MPI version of this code, which really works very, very nicely. And that's now allows us. This didn't scale at all on Archer on an MPI type computer. This now works fine and gives us access to Archer as a thing. Now, when you do these things, collaborations are important, and all these grants have 2 key collaborators. One is the Max Born Institute in Berlin, which went through a period of hiring all our students to upskill their R matrix to these people, and these people are still working with us on code development. And the other is my company, Quantumol, and I'll talk a little bit about that as well in due course. So as I said, industry involvement is important. All sorts of random schemes are appearing, which is, as I say, partly, well, for completely other reasons. I went to a meeting in the Treasury about 18 months ago, and the civil servant there said 2 things I never expected to be sitting in the Treasury and hear from a civil servant. The first of which was, we were talking about development of the company. He said at this point they normally register the company in the British Virgin Islands, which I thought was a slightly strange statement to be sitting in your government's Treasury office and be told. The second statement, a bit later on, was, of course, the government are desperate for Brexit to succeed. They're throwing money at everything. And part of the throwing money at everything is this sort of thing. So there's been a whole lot of fellowships trying to get academics to do things which are a bit more, well, not just fellowships, money of various sorts, to get academics to do things which are a bit more industrial oriented. So I got one of these. STFC do astronomy. So I got quite why they funded me. So what Bridget is actually doing is merging MolPro and Quantumol to give a joint computer program sponsored by Quantumol, but she's paid for by the government for 3 years to do this on one of these industry fellowships. They also have a long-running scheme for studentships, whereby basically if the industry put up a relatively small supplement, it's about a quarter of a studentship per year, the government gives you a whole studentship. That gives you more. That if you do the maths, that's 1 1/4 studentship. The student gets slightly better paid, and there's a bit of extra money in the grant for the project. So that's been a long-running thing that also supports collaborations with industry. As far as I know, in the atomic and molecular area in the UK, Quantumol is the only real company functioning in this space. Now, to get funded, this comes out of our AIMOR grant proposal. I don't want to leave it up too long. It doesn't bear too close inspection. For instance, like the ultra-cold chemistry and industry placed rather close together, I think is a bit of a stretch, at least at the moment. But the idea here is simply, it was drawn by Andrew Brown at Belfast, is simply try to show that we may be doing rather technical atomic and molecular physics, but we have impact in a number of different areas, which that this is not just going to produce interesting papers, but actually impact other communities.
Sorry, it
Yep.
does have an impact on you.
Good, tell me.
Well,
Yeah.
some quantum simulators are based on
Okay.
something called atoms and molecules and ions and all sorts of fundamental objects. And in order to understand the hardware, as I was pointing out, you actually, right?
You need that. Yeah,
You
yeah.
actually
Okay,
do need this.
I'll buy that.
Like Honeywell.
I'll
just
quote
like
your talk if I get pressed on it. No, that's good.
Yeah,
Good.
no, that's big image.
Yeah. And where we clearly do have an impact, the sort of thing Quantumol does is actually producing data for plasma modelling, which people pay money for. They pay us money for doing the simulating all sorts of things. So the UK ARMOR high-end computing also have this figure, which was my vision of how the project was going to turn really rather a large number of disparate codes into a single, if not a single code, at least a single intertwined organism. So you already had, Klaus put up, I think, 5 variants of Belfast R matrix codes already in his talk, which is this column here, doing electron atom, electron ion. There are since there are 3 variants of the UK molecular R matrix code, but one of them is pretty much moribund, the one which works on Slater orbitals. We have a new version which works on B-splines, and I don't know if Fernando Martin may be gone, but it was very like his picture. So you have an inner region with Gaussians and an outer region with B-splines. The problem is that this is being developed by one of the people who went off to MBI, and it's not really his day job. So whereas it works very nicely, it's still very much beta test version, so we tend to use the old traditional Gaussian version. What I put into this proposal as a new idea, something I've been working on a bit, is using an R matrix method for doing ultra-cold chemistry. So the idea is that you do all the difficult physics inside the box, and then outside the box you have S waves only, basically. So if you have to propagate for 50,000 atomic units, it's not actually going to cost you very much time. So, and then the idea is, for instance, we share outer region propagators, either time-dependent or time-independent. So there is interlinking between the various codes. So that's what starting this month, we've promised to do. And the idea here of these and the flagship projects is you're doing collaborative code development across several sites. To do that, we have agreed programming standards, which are actually published. I don't know how well we police these things. We have aspirations to do it. I'm not sure there's standards police that come in and post-test your code to see whether you've agreed to them, but in principle there's programming standards and documentation. As a matter of principle, though not always a matter of practice, like to publish my codes. It's actually hell on wheels. It's a lot of work publishing a code. Who is the biggest beneficiary of publishing the code? I think it's the future PhD students in your group. It's really useful for them to have the thing properly written up, documented, in a good standard, in a way that they can understand. It really makes them starting their project a shed load easier. I mean, there are all sorts of other beneficiaries. My code DVR3D I mentioned on the last thing is used by all sorts of random groups to do all sorts of problems I never even dreamt of when I wrote the code. And that's just, they can download it off somewhere and it's documented and they can get it working. So there is that beneficiary, but actually it's a very interesting internal beneficiary of doing this sort of stuff properly in terms of actually just your own group members starting. EPSA created a repository called CCP Forge, which I liked in principle rather more than practice. I mean, the principle was great. It was very over-configured, so it made it slightly difficult to use. Anyway, they announced 2 weeks ago they're closing it, so we're all busily moving to GitHub, which basically has a lot. I can tell you GitHub is a hell of a lot easier to use, so it has some advantages. And the general strategy we use when we're doing this, I wouldn't say this has ever been formalized, but by observation what I say is that if codes are published, they're published as a joint effort with everyone name on the paper. When you do physics with the code, the people who use the code to do the physics write the paper. You don't include everyone else who ever touched the code on that particular paper. You simply cite the coding paper. So that's the sort of general strategy used for that. So this is just a cartoon of RMAT React, and there's a sort of pre-paper, if you like, in Faraday's discussions a year and a half ago, just saying how we propose to do this and what we'll do with it. And really the reason I'm putting it up is I hope that some of you may have bright young computational scientists who are looking for a job, because I'm advertising one. Closes in June, but actually it's a 4-year grant. It's only a 2-year position, so I have a little bit of flexibility about when someone actually starts work and does working. But if you know someone who'd be interested in building a new code to do ultra-cold chemistry this way, please get them just to either email me and I'll point them the right way to apply. Okay, so Quantumol. So the original product that Quantumol produced was a GUI to run the UK R matrix codes. So what was happening was that the codes are freeware, okay. Codes are freeware, people wanting to use them, we'd say great, but they're impossible to use, so send your student postdoc yourself to UCL for 2 to 3 months. We'll train you how to do them, that's fine. Various people came, My then postdoc, Jimena Gorfinkel, had a great time entertaining all sorts of people. She struck up a very good collaboration, won the group, Leon Sanchez's group in Canada, as a result of training his PhD student how to use the codes. And I realized she wasn't doing any work on the projects I wanted to do because she was spending all that time teaching people how to use the codes. So an opportunity came up to actually start a company where what we did was write a GUI front end to run the code. So the GUI did the work. We charge people what it costs them to send their person to London for 3 months, not 3 years, so don't make that much money out of it. And that's where it's born. Now, it's interesting, we have some discussions of GUI already today. The GUI, in some ways, has taken on a life of its own, because people come to you and they ask for things that aren't in there. And you think, yeah, that's actually really rather useful. So dissociative electron attachment, company approach that says C4, F6, we really need the dissociative electron attachment cross-section. Well, you can do this properly for a diatomic. Forget it for a thing with 10 atoms, completely impossible. So I sat down the back of an envelope and actually reinvented the sort of physics that people were doing this in the 1960s to do it, just to get a benchmark money. It's good to a factor of 2. It's not the right answer. But, that comes in as an option in the GUI. It pulls out the right numbers and produces them. Similarly, we introduced BEB for doing ionization. There are actually other features. This is slightly old, slightly out of date. So the GUI in itself took on a life of its own. This code is now 14 years on. It probably took 5 or 6 years before it started selling seriously, but it's now it doesn't fly off the shelves, but we have a steady customer base. We also last year created a database. I think the important bit, the bit I like about this, it has an API that allows you actually to suck the data directly into your code. I mean, my view on modern data is it's so much of it, it shouldn't be going through human hands everywhere. It should be computers talking to each other. So I was very keen that we did it this way. And this is unlike most plasma physics databases that I'm aware of. It has both electron collisions and heavy particle collisions in it as well. And we have aspirations to put surface processes in. There are surface processes in there, but they're very crude at the moment. We want to do it properly. And the idea here is to produce complete, correct, and validated data. Complete, consistent, correct, and then validate the data as an aspiration. So I think that's what I was going to say about sort of the UKC. I'll make one sideways comment. Jimena said to me about a month ago she didn't think atomic and molecular physics or theoretical atomic and molecular physics in the UK would exist without Quantimal. Whereas that's a slight overstatement. There is no doubt that every single one of those grants I wrote, Quantimal has written a letter of support and said how important it would be. And when we got the referees' reports back for CSPQ, for instance, it was the first item mentioned by 2 of the referees that we had strong industrial engagement. So it certainly helps to have an industrial partner like that. Okay, I think what I was told to talk about was actually where we were on the discussion of scattering with light particles. Now, I think one issue didn't really come out in the discussion, which I think is quite important, that in this sector, not all of this sector, but quite a lot of this sector is mature calculations that work, and you're producing data for other people to use, which is slightly different from a lot of the very investigative things. Does quantum computing ever going to give you anything? That's a sort of very open question that you're trying to get an answer for. So to do that, I think you need to get into this area of uncertainty quantification. Actually, to produce data that someone else is going to put in there, and the people who are really pushing this was actually the International Atomic Energy Agency, who said all the nuclear physicists produce data. Why on earth can't the atomic physicists produce data as well? And I think it's a good question. It's a valid question. So we wrote a topical review a couple of years ago. There's a PhysRev editorial, not really telling you how to do it, just ordering you to do it as a matter of policy. There was a lot of discussion about GPUs and other advances in computational stuff. That's all fine. My view is that I don't particularly want to spend my time or my students' time writing the new linear algebra software, but it needs to be done. So one hope is that you get this either from the computer scientists or the manufacturers, but that's my personal take on it. But there's clearly are issues to be addressed there. The other thing which we sort of touched on, but we didn't go on, I think we're moving into an era where reproducibility of results is going to become much, there's so much been going on in the science, not just the science literature, the academic literature, about how people publish results and no one else can get these results. I think we're going to have to justify that our results are correct, not just publish them and say we believe they're correct. Now, you can do code validation by cross-comparing codes. We've seen some of that in this workshop, and that's clearly useful. This shows procedures are correct, your numerics are correct. Can highlight areas of improvement. I mean, I remember years ago Nick Handy coming to me and saying, why are my integrals an order of magnitude faster than his integrals? And I hadn't even thought about it until he asked me the question. And I came up, actually woke up in the middle of the night the following night and realized what the answer was. So you can highlight how to... No, I was using a different, well, maybe, but I was using a different formalism from him for doing it. We'd actually broken things down in Legendre polynomial expansion. It turned out to be, nowadays you do it in DVR and it'd be even quicker, but certainly in the electron molecule area, people tell you you've done a cone calculation or a Schwinger calculation or R matrix calculation. It's sort of garbage, because it's the model that matters, not the method you solve the model with. The methods hopefully work. They've been proved, they're mature, and I know, because I've reproduced some of Anne's calculations, that if I take Anne's model and put them in the R matrix code, I essentially get the same result. So that's a message. I think we need to move towards an area where if the codes are available, you can publish the input. Barry was saying publish the output as well. You certainly publish the results of it, so that actually there's a potential actually to reproduce the whole thing offline, someone else that could really prove that you're right. And then you need to also publish important metadata such as potential energy surfaces, which this is my end, this is the end of it, such as JCP are insisting on. So that actually we go to an area where it's not just this is the result my group got and you can do what you like and see if you can get it yourself. This is a result which you can take my code, you can take my data, and you can really get the same result and believe that for whatever approximation, whatever it is, that is the result you get as an outcome. Okay, so that was my thoughts on this area.
Thanks, Jonathan.
Yes, just to clarify, I wasn't
Yep.
suggesting 15-year-olds per se, although I think that's great,
Yep.
especially since my 15-year-old is just outside.
Yeah.
But,
Yeah.
What I meant is, graduate students and
Yeah.
undergraduates
Yeah.
to be able
Yeah.
to learn how to use the codes, right? So maybe you were joking about the...
Yeah, well, I didn't know what you meant by outreach,
Well,
what level it
maybe
was.
the graduate students are 15. But, okay,
No.
this is very advanced.
Yeah, yeah.
But I wanted to say this question about how things appear in industry and
Yeah.
what you do with codes that have, that could get supported by industry. I mean, that's a key question. In the U.S., it's addressed as part of this NSF program, actually, in some detail, but I don't understand the answers yet that they've given me, probably because I don't understand much about industry. But it would be good to understand that better. The quantum codes out there have been made, public source very fast, the ones for quantum computers, and that has been a concern for us, although because of our focus on quantum simulators, we're okay so far. But
So what I should have said, which I didn't for the quantum model, has what I consider quite an interesting model, because of course the codes are all open source. So quantum model is not selling the UK R matrix code, because that is an open source code you can download from a repository.
Yeah.
They're simply selling a GUI plus advice on how to run it.
I see.
So I can make no claims to owning the IP for the UK RML code, which has probably had 20, 30 different developers over 2 decades. So this is actually quite a neat solution. Academics can carry on using it,
Yeah.
but actually, we were sort of inspired by Gaussian, at least Pope's original vision for Gaussian, not the idea that we would ban people from using the codes, but the idea that actually you have a very important technique which has wider applications than the people who have the skills to use it at a detailed level. So the idea is that you can have plasma physicists running the code without actually having to know that much atomic and molecular physics. A bit like you were commenting on the various codes you were trying to run,
Yeah.
which were non-specialist.
Yeah.
So is that GUI for specific hardware, like run on a PC, or is it just in a browser?
It runs in its own environment. We have periodically made Windows versions, but basically most of our customers ended up buying a Linux box, even if they didn't have one. And we would prefer configure their Linux box for them than actually configure our code to run under Windows.
Connected to the Linux, the X.
Yeah.
So
Yeah.
it's not a browser.
No, it's not a browser based. It's an independent bit of graphics. It's not a browser based. It's an independent bit of graphics.
Well, I just wanted to
Yeah.
say that I've been experimenting with sort of these containers, as I mentioned,
Yeah.
in probably my way to
Yeah.
many slides. somewhere. And it actually is much faster and easier for a lot of people. You don't need the whole OS. You just, they download Docker, and then it's a one-liner, and they get everything they need out of Linux to run in necessary stuff.
We have some customers who work behind a firewall without any internet access, and I don't know whether I mean, we're actually in the point of completely rewriting the GUI at the moment because of this link with MolPro. We decided that actually, given that there's going to need a lot of changes, that we need a rewrite. So it is worth thinking whether we should do it in a browser instead of 15 years ago when we started. It was not really a way of doing it.
I want to encourage you that it's really super easy. It took me like a day.
Okay.
So it was that easy. I was kind of amazed.
That's interesting feedback.
Just something to think about. Yeah.
Yep.
I'm still experimenting with it.
Yep. And does that become dependent on which browser you use, or?
Well, honestly, I opened it in Chrome and in Edge, but because I have a silly Windows machine here, and now I tend to use VMware before, but now or VirtualBox, but now I didn't try every browser out there, so maybe it fails in Firefox. I don't know.
It depends on what you use. If you use some common library like jQuery, that is actually designed to make it run on almost anything. So I work only on Firefox on my Linux box, but it runs then in the Windows, and even on my phone it runs without any change.
I mean, Docker has an enterprise cost, that is true. I don't know what it is, but you can run it individually. If you're running a large-scale business, there's something associated.
Thanks, Jonathan.
Okay.
Christoph?